Yo, what's up, guys? Welcome back. Episode 157 today. Definitely been a long weekend with 4th of July. Just got back today, so thought I'd make a quick video here, maybe for an hour or so. Definitely pretty exhausted, but we're gonna jump through some problems today. So let's get started. Jump straight into it. My hair is long. I definitely need a haircut. Yo, Galactic, what's up, bro? How you doing, man? I've been gone all weekend, dude, so I haven't been able to jump on stream, bro. How was your weekend, dude? Given two integer arrays, nums 1, nums 2, your task implement a data structure that supports queries of two types. Add a positive integer to an element of a given index in the array. Okay. Count the number of pairs ij such that nums I, nums 1I. Doing some leak code, dude. Let's go, bro. What problem you doing, bro? Have you done this daily problem right here? Find some pairs, dude. Given two arrays, initializes the find some pairs object with two integer arrays, nums 1 and nums 2. Initializes the find sums object with two integer arrays, nums 1 and nums 2. Void add into index in val adds val to nums 2 index, i.e. apply nums 2 index plus or equal to val. In count in TOT returns the number of pairs ij such that nums 1i plus nums 2j is equal to TOT. What is TOT? Nums 1i plus nums 2j is equal to. No, I'm doing problems from that rating website. Are you doing 1500 level problems? Like what we were talking about a few days ago? I think that's what I'm gonna do. I'm gonna do this problem and then probably take a look at that problem I was looking at the other day. That 1500 rated problem. I'm literally so tired though, dude. I'm so excited to go to bed. To be honest, I really didn't want to. I really didn't want to jump on the stream today, dude. I wanted to go to bed so bad. You know, I'm not gonna lie. I'm so tired from the weekend. But I thought I just had to make a problem, bro. I mean, I had to do a. I had to make a video, bro. I couldn't make an excuse, dude. I start from the last page and then work up to page 1. Okay, that's a good idea. What are you doing between 1500 and 1550? Is that what your range is right now? Given two integer arrays, no, wrong. I have to understand this problem better, dude. Two integer arrays, nums 1, nums 2. 1500 to 1600. Okay. Maybe that's what I'll do. You're given two integer arrays, nums 1 and nums 2. You're tossed in. I always like to do the daily problem. I don't know why. I don't know what the satisfaction is doing the daily problem, but two integer arrays, you're asked to implement data structure that's false creatures. Add a positive integer element of a given index in the array nums 2. Okay. Count the number of pairs ij such that. Okay. Trying to think here. Solve.nums1 is equal to nums1. Solve.nums2 is equal to nums2. I think we're gonna need a thinking a dictionary here for the fast lookups, but I'm not sure. Is equal to counter. I have to import our counter class. Oh shit, dude. Go to import the counter class, dude. There we go, dude. Let's go, dude. Man, I think I'm gonna need to start wearing a hat, dude, on the stream. Hair is literally so long, dude. Literally need to go get a haircut. It's like in my eyes, dude. Maybe we have to solve dot. Let's call frequency 2 is equal to. Shit, what is it? Syntax? Is it counter nums 2? Yeah, I think that's right. Okay, so we initialize here. We're going to use a frequency map to iterate over this. So implement define nums class. So what do we do here? We add val to nums2 index, i.e. apply nums2 index plus or equal to value. Returns the number of pairs ij such that nums I. Okay, so we just return integer here. So really when we add here, what do we want to do? Our counter class here is just going to shit, dude, I have to look it up. Oh my god. Okay, so yeah, it's gonna count the amount of. So we're gonna have our keys as each value in the array, and then our value is going to be the count of all of them. So the way we want to implement this add function is that when we loop through nums, hang on, because really all we're doing here is we're adding, right? We add val to nums2 index, i.e. apply nums2 index plus or equal to val. Void add adds val to nums2 index. Is the index always valid that they give us? I'm gonna assume that. I'm pretty sure it should be, but okay. We don't return anything either, so what do we do here? Well, maybe we don't even need this frequency counter. I don't know. We'll figure that out in a second. Now nums2. So we add 1 here. Find some pairs 0, 1. So what? Our index 0 plus 1 from there. Okay, so oh shit, dude. What is the thing again? Adds val to nums2 index, i.e. apply nums2 index plus or equal to val. I mean, really, like, nums2 index plus or equal to easy, man. Feeling kind of blank here. Trying to think here. I feel like our counter can keep track of our values, right? In a way. I don't think maybe a counter is necessary here, but to me to think about it makes it a little easier. Right? Because I wonder. What does the count here do? Returns a number of pairs ij such that nums I1, nums I plus nums 2j is equal to TOT. I guess the easiest way here would just be to... Shit, man, is it storming outside for me, dude? Oh my gosh. I mean, really, I'm thinking n squared loop here, but I mean, we could probably do the complement too. I think about it, but let's check. One. Well, actually, we could probably speed this up with a counter here. So I feel like here maybe all val is equal to solve dot nums2 index. Right. So we get that number, we remove it from our dictionary. So we would go freak2 is freak2 old val minus or equal to 1. Minus equal to 1. Right, so we remove it by 1. We add the value. Right? And then we can go new val is equal to self.nums2 index freak2. Well, actually, is counter a default dictionary? I actually don't know. Let's check. Okay, I think it is. So we don't have to worry about the minus or equal to. So we can do freak2 new val plus or equal to 1. Right, so that should work. Now with the counter here, we can loop through for nums, for num in nums 1 in range. No, I think nums 1. Yeah, we can take our complement here, so actually this needs a self. Actually, are you missing anything with a self here? Maybe we need, I think we need a self here. Self.freak2. Alright, we come down here. We do for num and self.nums1. How would we take our complement here? So the complement would be the number that we currently have. Complement is equal to, how would we do this? Well, we take the value. No. Do the number that we're looking at minus our num. And then we'd want to check, well, if. So we have our complement. We want to check if complement is inside of there. So if freak2 if complement and freak2, can we just count? We need our count here. And then what, we just like count plus equal, no, we don't want to add it once, we want to add actually the freak2 complement, and then we return our count. I believe that should work. And then, well, we need a, that speeds us up. Otherwise this would be n squared, and I don't know if this would pass if this was n squared. I mean, we can use a for loop. That's kind of what our dictionary is using here, keeping track of these numbers of 1 right here. I think this should work. Probably got some sort of syntax issue, but freak2 is not defined, and self.freak2. There we go, dude. Go, dude. That pass? Let's go. Good start, bro. Good start. Little, kind of feeling it a little bit. Alright, let's take a look at that website. Where is that website that you had there, Galactic? Here it is. Okay. Let's jump in from 1500 to 1600. Go to page 12. Partition array. Okay. Given an integer array null is partitioned into 2 continuous subarrays, left and right, so that every element left is less than or equal to every element right. We have our left here, we have our right here. Left and right are non-empty. Nice. Appreciate that, dude. Thank you, bro. Thank you, Galactic. Left has the smallest possible size. Return the length of the left after such a partitioning. Test cases generated such that partitioning exists. I feel like this is some binary search problem, low-key. Given an integer array nums, partition it into 2 continuous subarrays. So we're returning an integer. Wait, it's not binary search. For left and right are non-empty. Left had the smallest possible size. Oh, wait, it's not binary search, dude. What am I thinking? I thought this is what we were returning here, not an integer. So, turn the length of left after such partitioning. Test cases generated such that partitioning exists. It's damn tough. 1500 problems, Galactic, pretty tough, right? Like 1500 in LeetCode. Because I'm not sure, dude. I'm not good at this shit, so I don't know. 1500 like refers. Oh my gosh. 1500. 1500 rating. Code. Intermediate level of proficiency. It's just user has a good grasp of fundamental data structures. Yeah, I don't know. These are tough problems, but it's alright. We'll keep going. Okay, return the length of the left after such a partitioning. No, that's like normal. Alright, fair enough. I feel like there's like much more like, you know, this is a 49% acceptance rate. You know, there's like, I don't know. Use prefix and suffix array to store the maximum and minimum element in the ith position. I'm confused what we're looking at here. I don't feel like I'm understanding this problem. 1500, 1700 is like someone who can solve 1 to 2 questions in the contest. Ah, okay. Alright. Fair enough. Let's position it to 2 contiguous subarrays, left and right. Trying to figure out what the best way is to solve this. Okay, so we're splitting here. Okay. I think there's a common pattern here. We're actually just cutting the array in half. So... So these are our rules. Every element in the left is less than or equal to every element in the right. Okay. To my eye, bro. Left and right are non-empty. Left has the smallest possible size. Left and right are non-empty, so there's something always in left and right. Okay, let's just do, well, if num's 1. If not, num's... Guess we would just return 0. Alright, just get that out of the way. Left has the smallest possible size. Every element at left is less than or equal to every element in right. So I guess we're finding the point that it kind of cuts off here, in a way. So really, is every single time... I feel like the... You use Mint. You're using Mint? I am edit, dude. I'm using Mint. Yes. Linux Mint. Cinnamon. I'm not very much a Linux bro, but I switched a couple months ago, so it's pretty chill though, dude. Kind of like it. So I dual boot though. I have Windows and Linux, so okay. So the way I'm kind of thinking about this problem, to be honest, I have kind of don't really have a good idea about how to solve it. But just to make sure here. What's the problem name, by the way? 915 partition array into disjoint intervals. That's what we're looking at right now. We get 50386. So yeah, from my idea here is that we're looking for this point here, right? That splits between the arrays. This point right here, right? That splits the left side left is less than or equal to every element of right. So I assume here they give us an array and we're looking for that point right there. That points to two things for me. That I think of more of maybe this could be, you know, a prefix sum question, you know, a 2-pointer question, or maybe it could be some sort of like modified like binary search question. Do I know? Probably not. I did see a guy say prefix sum down here somewhere. I do think that would work, but I'm not sure kind of how to. This guy gives a hint here. Take two arrays, max left and min right. Max left element should be less than the min right element for an index. Pretty interesting. Definitely is, Edit, dude. Definitely is. Tough problem, dude. Max left element should be less than the min right element for an index. Max left should be less than min right. Take two arrays, max left and min right. This hint isn't really helping me here. So we take two arrays, we find a max of the array, we find a minimum of the right. The max left element should be less than the min right element for an index. Should be less than the min right element. Okay, well that's... I kind of knew that in the question. Return the left after such a partitioning. Every element left is less than or equal to every element right. Bro, my hair, dude. Need to go get a haircut. So bad, dude. Let's maybe try and get some ideas from the internet about how to solve this problem, how to think about the way to solve it. Yo, curious question. Why would you rather do this than actual project, or am I missing something? I work on stuff, dude. Not sure. I work on my own projects in my spare time. So I don't just do this. I just do... I mean, I could stream myself, like, making projects, bro, but I don't know. I get kind of distracted a little bit, so I just thought about... I literally stream for, like, an hour and a half. I just do, like, a couple problems a day. That's really about it, just to kind of get in the groove of, like, problem solving and stuff, thinking of the problems like that. And I'm nothing amazing either at doing them. I'm pretty average, I feel like, but just to kind of help with the problem solving and, you know, thinking these, like, just getting that intuition about how to solve these problems. I mean, I feel like it can just benefit you, you know, in some way. So I do them. And I also kind of enjoy doing them, to be honest. They're kind of fun, so. Okay, we got a problem summary here. Fair. What do you do, bro? What sort of stuff do you work on? Not sure. To be honest, man, I'm not sure how to solve this problem, dude. I don't really know. See if there's like a little video maybe someone did. Nope, no video that I want to watch, to be honest. Let's take a look at the hints. Great, array, let's go. You know what would be more fun? Make a JS thing that gets your submission, and if it's incorrect, it just deletes root chromogen. Let's go, dude. Good joke, bro. Yeah, that would be an L, dude. That would be an L. Let's see here. That was the best stream I've ever watched. I'm sure it was, dude. Damn, bro, we just have the same to do things until we get a job. Just have the same. Yeah, bro. I mean, just working on some leak code problems, dude. I've been doing it for a little while though. I've been, not gonna lie, I've been pretty consistent with it. Like I mean, you can see I kind of started in September, but I've been gone for the 4th of July weekend, so you know I haven't done some problems in a few days, but you know I've been pretty consistent with it. I do a couple problems a day. I don't know, so done a decent amount, but I don't know. I still don't think I'm really very good, dude. It's hard for me just to. I feel like the hardest part is just getting that intuition about how to solve the problem. Like I generally don't know how to think about solving this. Have you solved this, Galactic? You want to give me a hint, dude? I feel like you've probably solved this 1500 level problem. Let's see here, dude. I mean, let's walk through this. So the internet says take a left maximum, curve maximum. Let's take a look here. So what do we want to do? We want to take a left max, right? So hang on, let's do a different color. Let's go yellow, dude. So we want a left max, right? We want a current max. And then we want our P index, where we want to partition from. Haven't solved it myself, going to now. Yeah, dude, let me know if you can solve this, dude. Let me know what you think. Not getting the intuition here. Yeah, I have solved it, but it was a long ago that I might have forgot. I do something like a prefix and a suffix on. Yeah. Yeah. I think that's what. I haven't looked at the solution yet, but I'm looking at like a step-by-step plan. I'm trying to think about it. Let's see here. We get a left max here. We initialize that to num0, right? Oh shit, dude. num0. That's the biggest L, Galactic, dude, when you solve the problem and like you can't remember how to solve it, dude. I get that all the time, dude. Sometimes I go back to problems and I cannot solve it. So we initialize that all to num0, and obviously our index is 0, right? We want to iterate from the first index, right? I assume that's probably because we've set our current to be this one, right? We loop through, update our current max is equal to max current max num0. So we're looking for our max, right? And we're looking for we have our left max. Oh my gosh, dude, it was that simple? Really, bro? It was that simple? I understand now, dude. Oh my gosh, bro. So we have our current max is equal to num0. Our left max is equal to num0. And then we have our P index, right? Is equal to 0. We loop through for I in range. I think there's a faster one, bro. See, I thought about this problem, dude. I mean, I knew that you had to find this value, right? I should have. Let's see if I can think about this. Find range 1 to nums, right? What do we want to do here? We want to do, okay, well, we want to look at the max every time, right? So let's do our co-max is equal to the max of co-max and nums I, right? We look for our max, right? So we're updating our max every single time, right? Then on every iteration, we want to move our index, right? So if our index, ooh, shit. What part of the, sorry, I haven't looked at the chat in a second. At the moment, yeah, along with GLFW, nice. What part of the Learn Open NGL tutorial are you at? I could think of O of n squared. I think you can do it a little faster edit, but yeah, I mean, I feel like if you just solve it, to me, that's good enough. I'm not really using it. How are you thinking about it in an n squared edit? I'm not really using it at the moment, to be honest. I already got the basics down, so I'm just trying to get a renderer up. What is this tutorial that you guys are talking about, Galactic, and not sure? The open, what'd you call it? The Learn Open NGL tutorial? Learn Open NGL. Oh shit, dude. Is this a complete tutorial then? Of building a game engine in C++? Oh shit, dude. Is this completely free too? Fuck, man, this website looks ancient, bro. Oh, you already have the lightning. You already have the lighting stuff. Man, dude, I feel so behind, dude. I've been wanting to learn how to do it, make a game engine. All this stuff is completely free, dude. That's pretty cool. Let's go through everything. Nice, dude. Cool stuff, man. Anyway, back to this problem. See, I get distracted, bro. I get interested in what you guys are doing. Okay, so I take the max here. How do I want to think about this? Well, this is the index we're going to return, right? So this is, I'm going to switch our color here. Our current max is pointing here, right? So every single element we loop through, we're going to find our max here, right? So if our max our left max is probably something for Python, even if it might be a little bit slow. I'll teach you something. Yeah, bro, I'm definitely interested. I'm actually learning C++ right now with my buddy. He's working on a game engine. He's usually in the stream, Ethan. I think he might be busy, but I've been trying to get up to scratch with my C++ too, so like a rapper. Okay, let's think here. Initialize our left max here to be 0 as well. So really, I feel like I guess we want to check, well, if our left max is if nums I is greater than left max, and left max is equal to nums I, and we move our no. if num's I is less than our left max. Because if it's probably something for Python, even though it might be a little bit slow, I'll teach something like a wrapper. Oh, sick. Yeah, bro. It's C++ is tough, dude. It's tough to wrap my head around the syntax. I've never really kind of, I mean, in college, you know, like, you know, you learn about memory management, and I, you know, did a little bit of C programming and stuff, but I don't know. I feel like that shit doesn't really matter. Like, I didn't really do anything at the end of the day, so it's like, you know, I really got to learn myself. I feel like that's really the only way you can learn properly, is just working on your own stuff and learning in your own time. But yeah, I'm getting the syntax. I'm getting the syntax so far, so it's been good. I've only been learning, I think this is my second week, but bro, I've been so busy, dude, like with work and like the 4th of July weekend, and this week coming up is my birthday too. It's my birthday on Wednesday, so C++ is fuckery to me. C is a lot easier for, at least to me. Yeah, I don't know, dude. They're both hard to me to wrap my head around, to be honest, dude. But it's fun. I like learning and stuff, so it's pretty good. Okay, so if num's I, right, is less than our left max, right, then we want to move we don't want this, but we probably want to move our P index, right? P index is equal to I. Oh, I think I just got a solution question. If you run two for loops separate to each other, is that O of n squared? No, I think that's still O of n. If you're talking about like, yeah. If you're talking like this, where that's separate like this, then yeah, but if n squared would be, you know, a nested one like this. If num's I is less than left max, then we can move our index, right? We would go to here. We go to here. And then we would return. Let's see if this works. Definitely will not work for every test case. Happy birthday. If I don't get to say it, then C++ syntax is like hard part for me. 2 times n. I think 2 times n is still n, bro. I'm pretty sure. Just, it's still O of n. Thank you, bro. My birthday's on Wednesday. I still plan on streaming on Wednesday. I don't really do anything for my birthday, so I'll definitely jump on and do leak code or something. So, yeah, you guys will see me on my birthday. I'm pretty excited. I turn 24 though, dude. I'm getting old, man. Getting old as fuck. So, anyway, so I feel like here we would only really get to this part here, right? Because once we see something that's higher than our max, then I feel like we'd probably have to return the index plus 1. So let's see how this goes. Might be there then. Yeah, dude. We'll I'll try and do something fun on the stream. I don't know. List object cannot be interpreted as an integer. I think this needs to be length. Whoops. Length nums. Low key. Oh my gosh, dude. If this passes, bro, that's crazy, dude. I didn't think this would pass. I thought for a different test case, this definitely would not pass. But maybe it always goes down. So that's why I wish there was more test cases, bro, because this is like, this would be crazy if this submits, bro, low key. Like, oh, bro, I thought it was going to submit, dude. Anyways, I'm off to sleep. Best of luck. Thank you, bro. Thank you, Not Sure. Nice to meet you, dude. Hope to see you again. Damn, bro. I thought I was gonna solve that in a second. Okay. Anyway, we get another test case, dude. So that's a dub to look at. That's a dub. Let's take a look here, bro. Okay, so 32, 57, 24. You can make test cases, you know, dude. I had no idea you could make test cases. How the hell do you make a test case? Contribute a test case? No. How do you get more, bro, on the website? I have no idea, dude. I haven't really looked that far into it. I just try and solve it. I'm okay. So we got 32, 57, 24, 19, 0, 24, and 67 is right here. I think this is where we want to split here, right? Output 6, 0, 1, 2, 3, 4, 5, 6, 7. Okay. Search random set generator, get a set of images, and paste it. Oh shit. Okay. Fair enough. Yeah, I didn't really think about that yet. That is true. I could probably do that. Beside the test result. Oh, test case here. Oh, okay. I understand. Yeah. You can hit the plus icon. Okay. Thanks for that, bro. I didn't even know you could do that, bro. I appreciate that. So really, what are we doing wrong here? If we were to run through this code, so we start off here. We start at 1, right? We're not really doing anything with our left max here, so I feel like we gotta move our left max as well. If numSI is less than our left max, otherwise maybe if it's not, we move it. Left max is equal to numSI. Oh, no, well that passes that one, but doesn't like this one. Okay. Maybe actually, instead of it making it to the value that we look at here, that works this, maybe we can just make left max be equal to cur max, the value that we're looking at. Let me think. Left max is equal to cur max. Let's take a look here, right? Let's run it. Let's run through the test case. Let's get rid of this shit. Let's run through this test case here. So we got 32. We got 57. We got 24. We got 19. 0. 24. Shit, man, this is long as fuck test case, dude. I can't even. Fuck, dude. I'm gonna have to make. I'm gonna have to make this smaller, bro. Like, hang on, I'm gonna write it over here. It's probably easy to see for a second. Okay, so we got 32. Is there a drawing thing on the internet, dude? Oh shit, no. Okay, that's better. Oh, bro, I lost my test case, dude. Fuck me. Okay, whatever. We'll work with this one. Drawing pad? I don't know. Sketch pad. This worked, dude. Oh man, this one looks garbage, dude. Start drawing. Ah, this is garbage too. Anyone have any? Going to solve this right now on CPP. Gonna be back once I solve it. All right, bro. The best is on the internet. Xcali draw. Okay, I'll take a look at that. Xcali draw. Oh, dude, this looks goated, bro. This looks goated. Oh shit. Whoops. Let me start drawing, dude. Okay, perfect, bro. Goated. Thank you for that, bro. Thank you. Okay. Work with this test case. 1, 1, 1, 0. Oh, cannot draw. 0, 6, 12. Right? Okay. So we set our C max, right? Is our first value here, right? So let's make that look better. Is equal to 1, right? Our left max is equal to 1 as well, because we're making it equal to the 0th value. It has dark mode too. You can copy and paste the test case. Shit, dude. No way, bro. Bro. Dude. Galactic, that's pretty sick, dude. That's pretty sick. I actually... How do you get the dark mode on, dude? Dark mode. Oh, shit. Oh, my God, dude. This is goated, bro. This is goated. Okay. Anyway. Well, we know in the future now we can copy and paste test case. So, anyway. Okay. So, we got it here. Everything is pointing here, right? Oh. Where's my drawing? Let's go to blue here, right? Oh. Cannot control Z. No, I can. Okay. So what we're doing here, every single time we loop through, we're taking the max value, right? So as we loop, right, we're updating our max here, right? So our max here is always going to be, in this test case here, it's going to be 1, right? Because we're looping, we're always checking our max, okay? If numsI is less than left max, which it's the same every single time, but it's less here, right? So it comes here, it's less, which is what we're looking for here, right? If it's less than max, we set our P index. Put this down here, right? We make our P index equal to this value, right? And in this case, this value be 3, right? So we'll be at 3 here. We set our left max to be our current max, right? So instead of the current value that we're looking at, which is why we failed that test case originally over here, right? Is we would make our left max to be equal to what it's currently at. In this test case, it's going to be 1. I mean, we've only looked at 1, right? We've been updating it each time, right? And then when we find something that's greater, right? If our numsI is greater, we're going to loop through this, right? And we're going to return 3 plus 1, 4, which is our output, right? So that passes this test case, right? If we were to go back to that other test case, dude, do you know how I can get that out of the test case, Galactic, or no? Like, I guess I can, make my own, dude. I guess this is probably a good time to make my own, right? Like, let's do like shit, dude. How do you generate those test cases again? Oh, keep grinding. Thank you, Dominic, bro. Appreciate that, dude. Thank you. Can you? I'll just generate one actually. Hang on. 515 addition array. Go to submissions. Oh shit, dude. Dude, you're so smart, Galactic, bro. Good thing I got you, bro. Good thing you're helping me out, dude, because I cannot remember these simple things, dude. Thank you, bro. Okay, so we got this test case here, right? Let's get rid of this shit off the screen. Alright, here we go. Copy this test case. Oh, whoops. Sweet, dude. Okay. Cool. Okay. So we got this test case here. Oh, make this a little smaller actually, bro. Okay. Oh my gosh, dude. Bro, still too big. Keep going, brother. Thank you, dude. Thank you, home of the world. You keep going too. You can just move the canvas. Oh shit. Oh shit. Okay. Sweet. Okay, so we're looking at this test case, right? Thank you for that, Galactic, bro. Appreciate it. No need to delete. Okay. Thank you, dude. Thank you for showing me this, dude. I'm going to keep using this. Okay. So we're looking at this test case here. We've got again, we're going to look at our Cmax here, right? Our Cmax being our first value, right? So here in this test case, we got 32. We got our left max here. We're just going to run through this super quickly just to get the feel, right? And then we got our P index, right? Right, that starts off at 0. We'll use a different color to loop, right? We got green here to loop. Okay, so we're going to loop through. We started our first value. I mean, we've already looked at the first, our 0th value, right? Because we've made our max, our left max there. Anyway, every single iteration, we always check for our max, right? Check for our max, come here, update our max, right? Here, our max is 57 now, right? We loop through. If numsI is less than left max, right? In this case, it is. We update our P index, right? In this case, our P index will be 2. And then we set our left max to be our current max, right? And our current max is 57, right? We keep looping again, okay? We're at 19 now. We do the same thing, right? Make our left max. Instead, we would literally just increase this, make this 3, right? Is that what we're looking at? 0, 1, 2, 3. Yep. Okay. Then we look at 0, right? Do the same thing. We'd move this to 4. Go again. It's still less. We would move this to 5. So this is definitely the way we want to go about it. We got a 49. It's still less than 57, right? Because we're looking, num's eye is less than our left max. Our left max is 57. Therefore, we'd push this to 6, right? Let's double check. 0, 1, 2, 3, 4, 5, 6. And we get to 67, right? We get to 67. 67 is greater than 57. So what do? We don't do anything. We just update our Comax, right? Our Comax is now 67. We do the same thing. Update our Comax is 87. Go back here. Be 87 again, right? So this is what we're looking at. We're looking at 6 here, and we return the index +1. The reason why we do that is because really we're going to stop here at this value, but really the value we want to return is the value that's 1 greater, right? So I think this should pass. This kind of looks like it's going to work, right? So we return 7, right? In this test case here, I think we'd return 7. So let's take a look. Oh, shit, dude. Invalid test case. Whoops. I think it was this one. Let's remove that. I accidentally removed the other one, but it's whatever. Let's submit it, dude. There we go, dude. Let's go, dude. Goated, dude. Goated. Goated as fuck. Sweet, dude. Cool problem. Don't know what to do here. Should I do one more problem? I guess we can. Let's take a look. Man, dude. Let's make this a little bigger. Let's go. Thank you, Galactic, bro. Thank you. Thank you for helping me, dude. Appreciate it. You're a great help to me, dude. Thank you for showing me all these things. So appreciate it. Should we take a look at a graph theory, dude? I don't know. Probably not. Sort items dependencies. Definitely do these soon, dude. I need to relook at my Union Fine stuff. I think looks like the new daily just dropped. Oh shit, did it, dude? Maybe I should leave the daily for tomorrow, bro. You know, like, because then I don't have a daily to do tomorrow, dude. Shit, bro. This maximum number of events that can be attended. We'll take a look at it though. Okay. Let's see what this is rated, bro. I'm curious. Has this got a rating on? No way, dude. No rating. How about we just? I'll do one more problem, but I'll go back. Let's go back and look at something that I've done in the past, just to get that feel again. You know, something that I've done before. What do we want to do? Construct a binary tree from pre-order, post-order. What should we do? Maybe a DP problem, dude. I don't know, dude. What should we do? Let's take a look at this, because I feel like this problem, when I looked at this problem originally, this one was tough. I remember looking at this a few months ago. When did I solve it? March 28th. So I solved it about 4 months ago. Let's see if I can solve it. So I remember this problem requires a lot of like knowledge about the way trees work, and I was kind of learning about it a few months ago. Given 2 integer arrays, pre-order and in-order, where pre-order is a pre-order traversal of a binary tree and in-order is the in-order traversal of the same tree, construct and return the binary tree. So they give us 2 lists here, a pre-order and in-order. We got our array here and another array over here. We're given everything here. So a pre-order is a pre-order traversal of binary tree, and in-order is the in-order traversal of the same tree. Well, you can try 1253. I just did it 2 to 3 hours ago. 1253. So 1253. Which one's that? This one. You did this one? I don't really want to look at. I'll probably look. I mean, dude, I'm gonna keep going through this. I kind of like your idea with the that ELO website. I'm gonna keep doing that, but I just kind of want to just go back to a problem that I haven't looked at. See if I can kind of think about the way to solve it. I do remember when I was looking at this problem, the way I thought about it. Right. I did. So we're given this binary tree, right? And we're given the pre-order traversal of this one, right? So what do we get? 3, 9, 20, 15, 7. And what do we have to return? Construct a binary tree from pre-order and in-order traversal. There was a special trick with this, bro. I just don't remember the trick. I remember... Okay. I think we need a... Pre-order traversal. Let me take a look at this. Visiting all modes, binary tree. Root left, right. Right? So we're given... Is this our binary... I assume this is our binary tree, right? That they give us? No, I feel like that's the... We want to... Okay, we want to return the binary tree. So we actually want to return a normal binary tree, right? A normal binary tree... hang on. I have to look up the... to look up pre-order and in order. It's tough to think about the trick, dude. Okay, so in order traversal. Let's take so hang on. Pre-order is root left right, right? Yeah. Okay, root left right. Let's write that down. Root. Shit, man. Root left right. Dude, my handwriting on the computer is so ass, dude. And then our in order here. What would in order be? Like, in order would be left, right, root, right? In order traversal. If we're doing it in order, it would be left, right, root, right? Storming outside my house, dude. What is in order traversal? Wait, what happened to 915? You solved it? I did solve it, dude. Do you want to see the solution? Sup, mate? What's up, Jonathan Chan, dude? How you doing, dude? Yeah, how did you solve it, Edit? Did you finish it? I think I got it over here, actually. No. You want to see my solution, dude? Yeah, I solved it O of N. No, this is the other one I solved earlier. Shit, hang on, let me refresh this. This is how I solved it, bro. That was my solution. I just messed up this this one right here. I was making left max be the value that we looked at, but I realized, I mean, that can be wrong depending on the test case. So, how did you solve it, Edit? How did you solve it? I'm curious to know. Let's get rid of this shit. And what problem are we looking at, bro? It's our daily problem for tomorrow. Okay, here we go. Right, in order traversal. No, it would be root left node. Why am I thinking left right root? It would be no. Left root right, I think, would be in order, right? Left root right? Yeah, left root right. Left root right. You know, solving it right now. Let me know if you let me know how you solve it, dude, when you do. Definitely with that problem with me was like kind of visualizing it out. I mean, I don't know. Had to kind of look up and understand like the problem properly and figure out how to solve it. Interesting. I'm plugging my ears actually, still solving it at the moment. Yeah, bro, you'll get it. You'll get it. It's definitely tough though, dude. I mean, it is a tough problem. Okay. Dude, I think I need to revisit. If you get this question, they do not want to hire you. Getting some problems with when there is a zero. Getting some problems with when there is a zero. I think you're looking at test case 2, bro. You gotta, that's the one I was messing up too. Are you using my code or are you starting from scratch? Just curious, like, I'm not sure how I can maybe assist you. Alright, we'll do. Dude, man, I don't remember how I solved this, dude. Got our pre-order here, right? Root left, right. Root left, right. Left, right, root. Yeah, dude. I don't know. I'm gonna have to look at a video on this one, dude. I don't remember how I solved it, dude. I remember what the trick was. I have to read something. Construct a binary tree. I just remember, bro. I remember solving it, and I remember having trouble solving it. But when I watched the videos, it made sense. I just don't remember. It's like a special little trick with it, dude. I just don't remember how people did it. I don't want to look at the code, dude. Don't show me the code. Give it an order. Construct the binary tree and return its root. Nah, my code. I'll let you know when I finish. Just thinking that out loud, you know. Yeah, dude. That's totally cool, bro. Man, his website sucked, dude. Took several hours, no hint. Do you think this was a hard problem or should I have solved it faster? You know how to... You have any idea about this one, Galactic? Dude, I'm gonna take a look at my solution, dude. This is a... Wow, what a simple solution right here. Take a look how I did it. So... Root tree node. Okay, yeah, we're returning the tree. Create our tree node. Pre-order 0. Index our root in order. Yeah, bro, what a tough problem. I wouldn't have got this, dude. I would not have got this problem. No chance, dude. I definitely looked at a video when I solved this problem, for sure. What are we doing here? So we're just checking if it's empty here. Creating our tree node from our pre-order, our 0th element from our pre-order. And that's because in pre-order, I think I'm coming back in pre-order, we have our root here, right? So we know what our root is, right? And that's why I think I start from the 0th element here. It's because we know our root. We index our root in order. We do a recursive root.left is equal to self.build tree. We pass in our pre-order. Okay, it's coming back to me. Yeah, I definitely watched Nicode's video on this, dude, for sure. Like, 100 million%. 1 to mid plus 1. What is mid, dude? Where is... Oh, mid's here. Okay. We index our root in order. So if we go from 1 to mid, so here if we have our pre-order here, 3, 9, 20, 15, and 7. And then our in order here, which is 9, 3, 15, 27, right? We have our mid, right? Dude, oh my gosh, I'm so bad at drawing with the mouse, dude. Okay, so we have our mid here, and our mid is our 0th element, right? This is our root, right? So we're building our new tree from our root, right? So we have our first value, right? We call root.left on build tree. And we pass in our pre-order here. And we slice it from our first element, right? Which is here, to our mid plus 1. In order.index. So where's our 3 in here? Our 3 is here. Because in our in order we go left, right? This is our left and this is our right. Oh wait, no, sorry. Wait, hang on. This is our pre-order, right? In our in order we have our left first, right? Because we have left. Then we have our root and this is our right, right? So we can think of our array as like our right elements here and these are our left elements. This is our this is our root for in order, right? So we call root.left. I told you it was a trick, man. This shit is always like, there's always a trick to it, right? We go from 1, right? We don't want to count the mid, right? So we go pre-order 1 because we know our root is 1, right? So we would go 1 to mid plus 1, right? Our mid here would be mid plus 1. I think we go mid plus 1 because we're looking for how many index values. I think this signifies our left, right? So pre-order from 1 to mid plus 1. Mid plus our index here. What is our index for in order? It would be 1 here, right? So we would go 2. Right? So we go 1 to 2. So I think it would be here is what we're looking at. And then we go in order mid plus. And our mid plus is always going to be right, right? So I think these would be our right elements over here. When we go right, we would go... Shit, I'm confusing myself now, dude. I'm confusing myself. Let's take a look at Nicode's video, dude. It's probably better we look at it. Taking the L on the problem, bro. Sometimes you gotta take the L. I'm curious, bro. What is this problem rated, dude? Let's see. I think we're looking at problem 105. It's not even on here. Right, is that what we're looking at? Oh shit. 105. Construct binary tree. Yeah, no, it's not rated. Okay. Okay.
Pete Gordon invests the way he wants to invest, with no minimums and no...
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve a pretty fun problem. Construct a binary tree from a pre-order and in-order traversal. So we're actually given two integer arrays
Shit, my bad.
representing a traversal tree, and those binary tree that the traversals are from. And it is technically possible. These two traversals have all the information we need. We just need to take that information and then deconstruct it and then reconstruct this binary tree from those. So just to verify it, let's go through this tree and actually do the pre-order traversal first of all. So first, we know pre-order traversal is you start at the root and then you process the current node, then you do the left subtree, then you do the right subtree, right? So let's just do the pre-order traversal. So we're starting at the root, we do the root node first, that's our and then so we're gonna actually do pre-order. Let's take a look at all the pre-order traversal is we start at the root.
We know this stuff,
then
bro. We know this
in
stuff.
order traversal. That's the then we take care of the right subtree, the root 9 to the root. Now we can process the root. We can take 3 and add it to the in order traversal 20, but we only added to this how that in order traversal that we were given. So we can see that what they gave us was correct, but now the question remains, how can we actually take these two arrays, these two traversals, and construct this tree? Well, it's definitely possible. Let me show you how to do that right now. That we're going to be using first value in tree. So the first fact is that the first value in pre-order traversal is always going to be the root, right?
Okay, we got that.
Right, we remember this is the pre-order traversal that we're given.
In pre-order, the first one's always the root.
Value in pre-order traversal is always going to be the root. So this is the first value 3. It's guaranteed to be the root because that's how pre-order traverse. Now we don't know about the rest of these, right? But
we use the information from in order.
Recursively construct now the left subtree and the right subtree, right? We're done with this 3, right? Now our goal is to reconstruct the left subtree. Hey, lucky for us, the first value here is always going to be the root of the left subtree, right? Because that's how pre-order traversal works, right? So that's one thing that we're going to use. The first value is always going to be the root, and then we can take the sublist, right? We can remove the 3. We don't need to look at it anymore. Then we take the sublist, and then basically we're going to do this recursively. That's what I'm telling you. Okay, we can construct the root, but we need more information than that, right? Array, right? And I want to know right subtree. From looking at the actual tree itself, we know the answer, right? We know that this is where we're going to cut our list, right? The 9 is going in the left subtree, right? These 3 values are going. We need our in order traversal array. In order traversal. And by the way,
here we go. This is where I got confused here. This part here, the in order part.
The traversal is guaranteed to be unique. That's true for both of the traversals, the in order and the pre-order. Every value is going to be unique because every value in the tree is going to be unique. But okay, so far we know that this first value, we know 3 is the root, right? So we removed it from our first list basically, right? But now let's find it in our in order list. So we know we don't need this 3 anymore, right? We already created that node. But
that's why they do the index here. That's why we slice from this part, I think.
Order array
this is left and this right. So I think that's really I think that's really all we need, right? Because technically, hang on, let me make this over here, right? Oh no, shit, this won't work. Leave this over here. Because, right, when we looked over here, index here, we recursively went our left subtree, we go 1 to mid plus 1, which is our pre-order. Our left subtree, right?
Notice 3 that we just created the root from. Every value over here, which is only 9, is gonna go in the left subtree.
Right, that's what we did here.
And every value to the right of 3 is gonna go in the right subtree. That's really convenient for us. Why is this the case? Because that's basically the purpose of in order traversal, right? It guarantees that we're gonna go through the tree in order, right? From left to right, basically. Right, so if we see the 3 here, and this is the position in the array, we know everything here is going to be in the left subtree, everything here is going to be in the right subtree. That's what it tells us. This is really convenient for us because we can count it, right? We can see there's exactly 1 value that's going to go in the left subtree, and there's a take partition subtree and continue this. We let the in order portion. this is the array, right? There's only one value here, and there's only, right? So 9 is the only node in the left subtree. So we're going to create that node, put the value there, and now we're basically done with this left subtree, obviously, because there's no...
Right, and that's why we go pre-order 0 here every single time. Tree node pre-order 0, we index again, and we do left from this root. Okay, that makes sense. Mid plus 1, that's the mid. We build the right subtree recursively. Go right from pre-order. Right from in order. Okay. I think I'm gonna call it there, just because I got some stuff to do. I gotta drink a protein shake, get ready for the gym tomorrow. Gotta work on my stuff, my other projects, so learning C++. So need some time to do everything, but I really appreciate all you guys' help. Thank you for showing me all these cool tools like Xcali Draw. Shout out to Galactic, what a legend. Thank you guys for watching. I will see you guys tomorrow. Yeah, appreciate the support and appreciate the help, and it was a good leak code session. So appreciate you guys. We'll be back at it tomorrow. Hopefully I come back to this problem. I kind of have that. Really what I was looking for here is really just that intuition. I feel like that's important. Just like identifying, you know, those pre-order, in-order things. You know, sometimes I forget the order of pre-order, in-order, blah, blah, blah. But yeah, it was good. So thank you guys for your help. But yeah, I'll see you guys tomorrow. So thank you guys. See you later.